In this video, we'll solve exercise 2.2 of chapter 2. So the question is, find the zeros of the following quadratic polynomials and verify the relationship between zeros and the coefficients. So there are two parts in this problem. First one is finding the zeros of the polynomial, and second is verifying the relationship between the zeros and the coefficients. So let's look at this polynomial expression x square minus 2x minus 8. So in order to find the zeros for this polynomial, we need to factorize this polynomial. And to factorize the polynomial, we need to split the middle terms such that we find two numbers whose product should be equal to the coefficient of x square, which is 1, multiplied by the constant term, which is minus 8. So the product should be equal to minus 8, and the sum should be equal to the coefficient of the middle term, which is minus 2 here. So 2x is the middle term and minus 2 is the coefficient. So we need to find two numbers whose product is minus 8 and the sum is minus 2. So for a moment, let's ignore the sign of these two numbers. So let's look at the product number, which is 8. So we need to find, let's start with finding the factors of number 8. So the factors is 1 and 8. This is one pair of factor, and the second is 2 and 4. Now if we look at 1 and 8, it can give the product as 8, but their sum cannot be 2. Whereas if we look at 2 and 4, the product can be 8 and their sum can also be 2. So if we take minus 4 and 2, if we do minus 4 into 2, we would get minus 8. And if we do minus 4 plus 2, we get minus 2. So we have got two numbers, minus 4 and 2, using which we can factorize this polynomial expression. So we'll factorize this polynomial. So we'll write x square minus, and we'll split this middle term minus 2x using minus 4x plus 2x minus 8. So if we look at these two terms, we have x as common here. So inside we'll have x minus 4, and then if we look at these two terms, we'll take 2 as common, and then inside we'll again have x minus 4. So now this can be written as x plus 2 into x minus 4. So now we have found the factors of this polynomial x plus 2 and x minus 4. Now in order to find the zeros, we'll put each of these factors to equal to 0. So if we put x plus 2 equal to 0, then we'll have x is equal to minus 2. Similarly, if we put x minus 4 equal to 0, then we'll have x equal to 4. So now we have found the zeros as minus 2 and 4. So these are the two zeros of the polynomial. Now we need to verify the relationship between the zeros and the coefficients of the polynomial. So the first thing is we need to verify the sum of the zeros. So sum of the zeros is equal to minus 2 plus 4, which should be equal to, and we know that the sum of the zeros should be equal to minus of the coefficient of x. So the coefficient of x is minus 2 divided by the coefficient of x square, which is 1. So on the left hand side, minus 2 plus 4 is equal to 2, and on the right hand side we have minus into minus 2, which is again become 2, and 2 divided by 1 would be 2. So this, we have proven that the sum of the zeros is equal to the minus of the coefficient of middle term divided by the coefficient of x square. Now let's verify the product of the zeros. So the product of the zeros is minus 2 into 4, and we know that the product should be equal to the constant term, which is minus 8, divided by the coefficient of x square, which is 1. So on the left hand side, minus 2 into 4 is minus 8, and on the right hand side, minus 8 divided by 1 is minus 8. So again we have proved that the product of the zeros is equal to the coefficient of the constant term divided by the coefficient of x square. Now let's solve the second problem. So the second quadratic equation is 4s square minus 4s plus 1. So now again we need to find the zeros of this quadratic polynomial. So we'll again start with the finding two numbers whose product is equal to, as I said earlier, product should be equal to the constant term multiplied by the coefficient of the s square. So here we have constant term is 1 and the product and the coefficient of s square is 4. So the product should be equal to 4 and the sum should be equal to the middle term, which is minus 4. So now again we need to find two numbers whose product is 4 and sum is minus 4. So we start with looking at the product term, which is 4. So we need to find all the factors for 4. So the factors of 4 are 1 and 4 and 2 and 2. So now if we look at 1 and 4, 1 and 4 product would be 4, but their sum can never be 4. So we are ignoring this pair. And if we look at 2 and 2, their product could be 4 and their sum could be minus 4. So if we take minus 2 and minus 2, so minus 2 into minus 2 would be 4, and then minus 2 plus minus 2 would be equal to minus 4. So now our terms are minus 2 and minus 2. So let's get back to this quadratic polynomial, and we'll write 4s square and we'll split the middle term minus 4s into minus 2s minus 2s. So we'll write it as minus 2s minus 2s plus 1, and then we'll take 2s as common here. So we'll have 2s minus 1, and then here we'll take minus 1 as common. So inside we'll have 2s minus 1. So now this can be written as 2s minus 1 into 2s minus 1. So now this equation, we see that we have find the factors of this polynomial, and now we can make each of these individual factors as 0. If you look at these two factors, they are same. So the factor, there is just one 0 of this polynomial, which is 2s minus 1 equal to 0. So 2s is equal to 1 and s is equal to 1 by 2. Now we need to verify the relationship between the coefficients and the zeros. So we know that the sum of the zeros should be equal to minus the coefficient of middle term divided by the coefficient of x squared. So minus the coefficient of middle term is minus 4 and the coefficient of s square is 4. So the sum, and then the sum of the zeros would be 1 by 2 plus 1 by 2. So now we know that 1 by 2 plus 1 by 2 should be equal to minus of minus 4 is 4 divided by 4. So 1 by 2 plus 1 by 2 is 1 and 4 by 4 is 1. Now we need to prove the relationship between product of the zeros. So the product of the zeros is 1 by 2 into 1 by 2. This should be equal to the constant term, which is 1, divided by the coefficient of s square, which is 4. So 1 by 2 into 1 by 2 is 1 by 4, and on the right hand side also we have 1 by 4. So this way we have verified the relationship between the zeros and the coefficient of the polynomial expression. Now let's solve the third problem here. So here the quadratic expression is 6x square minus 3 minus 7x. Now again we need to find the zeros of this polynomial. So we'll look at the try to find the factors of this polynomial, and again in order to find the factors of the polynomial, we again look for the product of two numbers whose product should be equal to the constant term multiplied by the coefficient of x square. Now if you look at this this expression here, the middle term has moved towards the right. It's the coefficient of x. The x term is the middle term, but they have moved it towards the right. So we need to look at the product. So it is equal to the constant term is minus 3 and the coefficient of x square is 6. So the product should be equal to minus 18 and the sum of the numbers should be equal to the coefficient of the middle term, which is minus 7. So again, we'll start with looking at the product, which is 18. So we should look at all the factors of number 18. So the factors are 1 and 18, then 2 and 9, then 3 and 6. So these are the factors of number 18. So if we look at the first pair, 1 and 18 cannot give the sum as 7. So we'll cross this. 2 and 9, the product can be 18 and then the sum could also be 7. So we'll consider this. And 3 and 6 again cannot give the sum as 7. So let's look at number 2 and 9. So if we take minus 9 and 2, then the product minus 9 into 2 would be minus 18 and minus 9 plus 2 would be equal to minus 7. So this way we have found that the two numbers are minus 9 and 2. So we'll write this expression as 6x square, and now we'll bring the middle term in the middle here. So we'll try to split this middle term minus 7x into minus 9x plus 2x. So we'll write here minus 9x plus 2x minus 3. And here the common bit, look at these two terms here. So the common number here is 3x. So inside would be left with 2x minus 3. And here we'll take just 1 as common, and then we'll left with 2x minus 3. So the expression would become 3x plus 1 into 2x minus 3. So now we have found the factors of the polynomial. So now in order to find the zeros, we'll make first 3x plus 1 equal to 0. So 3x is equal to minus 1 and x is equal to minus 1 by 3. So this is one of the zeros. And second, we'll try to make 2x minus 3 equal to 0. So 2x is equal to 3. So x is equal to 3 divided by 2. So now the zeros are minus 1 by 3 and 3 by 2. So these are the zeros of this polynomial. Now again, we need to verify the relationship between the coefficients and the zeros. So we know that the sum of the zeros would be minus 1 by 3 plus 3 divided by 2 should be equal to minus the coefficient of middle term, which is minus 7, divided by the coefficient of x square, which is 6. So now we have minus 1 by 3 plus 3 by 2. So we'll try to take the LCM here, which is 6, and here 3 into 2 is 6. So we'll multiply minus 1 with 2. So we'll have minus 2, and then 2 times 3 is 6, and 3 into 3 is 9. So we'll have 9 here, and here we'll have 7 by 6. So now we'll solve this. So 9 minus 2 would be 7 by 6, and here also we have 7 by 6. So we have proven that the sum is equal to, sum are equal. Similarly for the product, so when we multiply minus 1 divided by 3 into 3 divided by 2, this should be equal to the constant term, which is minus 3, and coefficient of x square is 6. So here on the left hand side we'll cancel 3 and 3, we are left with minus 1 by 2, and minus 3 by 6 is also minus 1 by 2. So the left hand side becomes equal to the right hand side. So we have verified the relationship between the coefficients and the zeros. Alright, let's solve the fourth quadratic equation problem. So now the fourth quadratic polynomial is 4u square plus 8u, and this is actually quite easy. So here we don't have the constant term, which makes it little easy. So if you look at these two terms, we see that 4u is common across both the terms. So we'll take 4u as common, and inside we'll be left with u plus 2. So now we have factorized this polynomial. So one factor is 4u and the other factor is u plus 2. So we'll first make 4u equal to 0, which gives u equal to 0. So 0 is one of the zeros of this polynomial. And second is by setting u plus 2 equal to 0 or u is equal to minus 2. So the zeros are 0 and minus 2. Now we need to again verify the relationship between the zeros and the coefficients. So first let's look at the sum. So the sum of the two zeros is 0 plus minus 2, which should be equal to the coefficient of the middle term minus the coefficient of the middle term. So minus, and the coefficient is 8 and the coefficient of the square is 4. So here we have minus 2, and on the right hand side minus 8 divided by 4 is again minus 2. So we have verified that the sum is equal. Now let's verify the product. So the product of the zeros is 0 into minus 2, and on the right hand side we need to look at the constant term divided. So the constant term is 0 divided by the coefficient of x square, which is su square, which is 4. So 0 into minus 2 is 0, and then 0 divided by 4 is 0. So we have proven that the product of the zeros is also equal. Let's look at the next problem. So here we have the quadratic polynomial as t square minus 15. So here if you look at it, we don't have the middle term, and this expression looks similar to our formula a square minus b square. So in order to factorize something which is similar to a square minus b square, we know the formula. This is equal to a plus b into a minus b. So here a is t square, so a is t, or a is t, and b is equal to square root of 15 here. So remember that b square, so the b square is 15, so b would be square root of 15. So we would write t square minus 15 in the form of a plus b and a minus b. So we know that t is a, so we'll write t, and we'll write b square is, or b is square root of 15. So the way we would write it here is t plus square root of 15 into t minus square root of 15. So this is the way we would factorize this polynomial. And these, now in order to find the zeros of this polynomial, we'll first set t plus square root of 15 equal to 0, or t is equal to minus of square root of 15. Similarly, we'll set the other term, which is t minus square root of 15 equal to 0, which means t is equal to square root of 15. So now the zeros of this polynomial are minus square root of 15 and square root of 15. Now in order to verify the relationship between the zeros and the coefficients, again we'll start with the sum first. So the sum of these two coefficients is minus square root of 15 plus square root of 15, which should be equal to the coefficient of the middle term. So coefficient of middle term here is 0 and coefficient of t square is 1. So minus square root of 15 plus square root of 15 would be 0, and on the right hand side 0 divided by 1 would also be 0. Let's look at the product. So the product of the two zeros is minus square root of 15 into square root of 15, and this should be equal to the constant term, which is minus 15, divided by the coefficient of t square, which is 1. So minus square root of 15 into square root of 15 would become minus square root of 15. Let's put a bracket here, and then this would become square root of 15, and here we have minus 15. So now square root of 15 into square root of 15 would become 15. So we'll have minus 15 here, and on the right hand side also I have minus 15. So this way we have proved the relationship between the coefficients and the zeros. Okay, so let's move on to the last quadratic polynomial expression. So here we have 3x square minus x minus 4. Again, to find the zeros of the quadratic polynomial, we need to factorize the polynomial. So we'll start with finding two numbers whose product should be equal to constant term, which is minus 4 multiplied by the coefficient of x square, which is 3. So the product should be equal to minus 4 into 3, which is minus 12, and the sum should be equal to the middle term, which is minus x, coefficient of minus x, which is minus 1. So we need to find two numbers whose product is minus 12 and the sum is minus 1. So again, let's start with looking at the product term here. So we need to find all the factors of number 12. So the factors of number 12 are 1 and 12, 2 and 6, 3 and 4. Now 1 and 12 will never give sum as minus 1 or 1, so we'll just cross it. 2 and 6 again cannot give the sum as 1, so we again cross it. 3 and 4 can give the sum as 1, so we'll add signs to it. So if we take minus 4 and 3, so minus 4 into 3 would be equal to minus 12, and minus 4 plus 3 would be equal to minus 1. So now we have found the two numbers minus 4 and 3, which will help us find the factors of this polynomial. So going back to this quadratic expression polynomial, so we'll split the middle term, which is minus x, into minus 4x plus 3x minus 4, and in this we have just x as common, so inside we'll have 3x minus 4, and here we'll take 1 as common, and inside we'll have 3x minus 4. So this expression would become x plus 1 into 3x minus 4. Now in order to find the zeros, we would put each of these factors equal to 0. So x plus 1 equal to 0, which makes x is equal to minus 1. So this is one of the zeros, and then if we put 3x minus 4 equal to 0, then this becomes x is equal to 4 by 3. So this is the another 0. So now we have the zeros as minus 1 and 4 by 3. Now let's verify the relationship between the zeros and the coefficients. So again, let's first verify the sum. So the sum is minus 1 plus 4 by 3 should be equal to the coefficient minus the coefficient of middle term. So minus, and the coefficient of middle term is minus 1, and the coefficient of the x square is 3. So now here if we take the LCM on the left hand side, so here we would have 1 into 3 is 3, so we'll multiply minus 1 with 3 as well. So on the top we will have minus 3, and here 3 into 1 is 3, so we'll multiply 4 with 1, so we'll have 4 here, and on the right hand side we'll have 1 by 3, as minus minus is 1. Okay, now on the left hand side minus 3 plus 4 is 1, so we have 1 by 3 is equal to 1 by 3. So we have verified the sum, and now let's verify the product. So the product of the coefficient is minus 1 into 4 by 3, which should be equal to the constant term, which is minus 4, divided by the coefficient of x square, which is 3. So on the left hand side, minus 1 into 4 by 3 is minus 4 by 3, and on the right hand side also we have minus 4 by 3. So this way we have verified the relationship between the zeros and the coefficients. Thank you.